Hi everyone and welcome to Design Week 2024. I'm your host, Ulysses Iñiguez, and this is day 3. Design Week is a 3-day virtual event consisting of a live stream portion and on-demand webinars afterwards. Day 1 was all about managed security, day 2 was for makers and rapid prototyping, and today we are talking about how to enhance your designs using AI and ML. But before we get started, I'm going to pass it on to Clifford, who will explain to you guys how you can participate in today's event.
Thank you very much, Ulysses. So like Ulysses said, my name is Clifford and I will be your host for the Q&A and comments section of this live stream. We are streaming on 3 different platforms, YouTube, Facebook, and LinkedIn, and I'm in the chat of all 3, ready to answer any questions that you guys may have and also to pass along questions to these guys. I would also like to point out one more thing. If you were to go to microchip.com/Design Week, it'll take you to this wonderful page right here. It gives you more information, frequently asked questions about our event, but if you click on this register for Design Week, it takes you to the On24 page where you can see all the different webinars that Ulysses was talking about that we've prepared for you guys. They're totally available on demand, so at your own leisure. And if you are typing up a question, but we miss it, feel free to email us at livestream@microchip.com, and I will make sure that the question gets answered. So without further ado, I'm going to pass it back to Ulysses.
All right, thank you so much. Earlier this year, we had a live stream which introduced our new MPLab Dev Suite, and today will be a continuation of that. So we welcome back Srirag to my left.
Thanks for having me.
Yeah, no problem. And then Kedar.
Hi, good to be back.
All right, so to get started, my first question is to Srirag. Today in this environment, where do you see AI and ML going in embedded designs?
AI/ML, when we talk about future of AI/ML, I would say it's very exciting stuff. At Microchip, we are all about pushing boundaries in what we can do in Edge ML. So in lines of that, you might have heard, we have acquired a company called Neuronics AI Labs. It underscores our commitment in this direction. What we are seeing here in this space is largely like hardware and software working together. The emphasis is more on the cohesion between these two entities rather than having a big, powerful hardware doing everything. So there are constraints like inference time, power usage, deployment flexibility. So keeping in mind the software has to work hand in hand with the hardware. So that's the space where it's going. For us, it's all about customers. So it's all about the end user who can take the product, take the idea and go through the whole tool without having to do much effort from their own end. So we have put the MPLab ML Dev Suite completely into the MPLab X environment, which is a familiar tool, and you don't have to go outside the tool for anything. Like you don't have to go to a Python environment, external environment or anything. It's everything inside, so it makes very handy for them. So long story short, we have, it's all about collaboration, innovation, and empowering the end user, to give them the best advantage to get the next digital product or AI product into market. So we are also bringing in a lot of libraries. So it's everything going hand in hand right now.
All right, that sounds great. Sounds like it can be very beneficial for a variety of applications out there. And I'm just curious, ever since the launch of the MPLab ML Dev Suite, what has been the response?
Oh, that's an excellent question. I would say, I must admit, it's overwhelmingly positive, both in our existing customers and the new ones alike. The compactness of our solution is very much appreciated about from our 8-bit ML customers. They have already integrated them in their systems. In the 16 and 32-bit sectors, we have industrial and audio-related applications which demands high reliability and signal fidelity. All in all, for us, it's like having a tool that you can do everything in a fully automated way. So that's one aspect of the tool that is garnering most praise. Like you build the tool without having to code. It's plug and play, one-stop shop for everything. So the thing that stands MPLab ML Dev Suite apart from other solutions is that you can take an idea, or not you, I mean anybody, like any embedded engineer that can take an idea, hypothesis, and get it into market, into production as swiftly and as confidently as possible. So that's our niche here.
All right, thank you so much. Last time we introduced our UI for our dev suite, and so today we're going to go through another application. Kedar, do you mind walking us through another application?
Yes, definitely. I have a new application video to flex a little bit about our tool's capacity of building 8-bit models and which can be flashed onto any 8-bit MCU and just get it working. So here I have a video. I have a demo in which we basically are trying to sense light around the system. So for this, we have used two boards. One is the Explained Pro I01. That's where the light sensor is, and the other one is the AVR-DA 128. That's the 8-bit MCU. So this project was basically developed by one of our engineers to just showcase how compatible we are with the 8-bit MCUs and how easy it is to build small footprint models. So yeah, I'll just walk you through this whole demo, but I won't go too deep into the UI part, but I'll show some interesting stuff later on after this demo. So yeah, let's get started with it. Here I'm inside my project space. The project is torch demo because I'll be using a torch to basically create the different light surroundings. So you get to the project summary page wherein you can see all your work until now in this project space that has been saved, like the captures, those are the data files. Then we have the queries, we have the pipelines, we have the models, the segments that were created inside the data files, all those things out over here. And the sensors that were used, the labels, and the date and the size of this model. Okay, so this project space, everybody must be familiar with this by now who has used this tool often. So the important thing over here is to see into the project settings wherein we have the segment labels and we have the metadata. So the segment labels is something that I'm targeting to classify using this model. So over here I have few classes like sensors being covered, if the torch is at full luminance, or if it's in the torch is at mid, low, and blink, or it's like the surrounding is just ambient lighting. So overall, this project can find its application in various use cases, like wherein there is a requirement of setting up the luminance, dynamic setting of this luminance based on the light surrounding it. So that's what our motto was for this project. The second thing is the metadata. In this case, we have kept it really simple. So just the metadata is the properties that you can tag to the data files that have been captured. So in this case, all the files were captured inside the office itself. So we just created a metadata saying office, and that would be in which kind of maybe in my cubicle, or it's in the some boardroom or some other room that the lighting was different around. So that metadata has been created, but you can go ahead and create more and more metadata fields, like the users who have collected it, or whatever you want to do. The next important thing is we move to the data manager, inside which we see all the files that have been captured. For each label, we have around 5 different data files. And inside those files, you see the signal and the segment that has been created for the that label, and it has been tagged to the correct corresponding label. So the information regarding the start and the length of the segment that has been created. You can even zoom into these labels and see different things, like you can see the signal properly. So with using this just zoom in and zoom out feature down here. So once done with that, the next part is the preparing the data for inputting it into the main model. So in prepare data, what we do is basically we create a query which would be kind of conditions put on the input data that would go into the main models for building. So These conditions could be something like if I want to create a model and just drop one of the labels, or say like I want to drop some of the metadata fields, like I can have something for training and testing, different files for these two categories, then I can drop it using this query filter over here. And the session that I'm right now, and I can just see how the data is well spread across the like the spectrum. So I can see the ambient lighting, like torch, mid, full, blink, covered, sensor covered, all these categories out over here. They are distributed by segments, they are distributed by labels. Also, we see the segment length distribution as well. So you just get the segment sample size versus the count over here. We move on to the most crucial part of this whole tool. That's the build model stage, wherein you would be basically creating a pipeline that would be the actual model itself, like the parts of the model that you would set using this pipeline, and that would start the training process. So here I've created one pipeline using just the basic pipeline, create pipeline template that we have on the first page. So our idea behind this was that just keep it at default settings. Don't touch it. Like we didn't want it to put our own ML knowledge into this while doing this, creating this project. So just leave everything at the default settings and let the auto ML do its magic to find the best solution. So we just wanted to test that out more and more. So we left everything at default. In that we have like first of all we have the pipeline settings, wherein we have the size optimization targets, like the size and the max SRAM size that it can handle, and like what's the target for, like we are targeting F1 score in this case, but you can also target like accuracy or sensitivity. The features to optimize, the search settings, these are everything, all of this left at the default values at itself. And the number of iterations is set at 2. That's also the default setting, and the population size is at 40. So once done with that, we see the input query that we created before in the prepare data state. Then the segmenter, which would be basically segmenting the data file and creating windows to process. That also, the values are again at default only, 250 and 250. We were lucky enough that this was the correct size that went to the MCU as well. So that's default. The only thing that we have changed over here, that we consider that we don't know anything about ML. So what we did was we included all the feature categories in here. But this is a kind of tricky one, because you tend to lose a lot of bandwidth of your CPU time and like all the resources that have been allocated to your license level. So based on that, make a decision. But for us, it was like just put in all the feature categories and let the tool do its work. So that also has been included. Rest of the things are like classifier, training algorithm. The validation again is a default, which would be stratified shuffle split. So that also is as it is. So after all of these settings, we just hit run pipeline. I'm just not going to do it right now because it might take a few minutes. So I'll just show you the ones that I've already created. So after processing and like after the training process is completed, you get the 5 best performing models, like we mentioned last time as well. So when we are using AutoML, there will be 5 models. But if you are going for the custom training mode, when you know something more about the ML thing, so domain, so you'll just get one final model that would be the best performing one. And over here, like our goal is to create really small models, which would be like going to the smaller chips as well. So basically, this would be ranked from 0 to 4. That's the 5 models, and most often the model that uses the less features for generating this results and like which has the best accuracy also, that would be ranked higher. So in this case, we see that Torch model 01, the bottom one is like it uses just 4 features, and it's 100% accurate, and the model size is also really small, so 599. And we get information about like all the other things as well, the pipeline and the like UID and other stuff. So that's done. We then move to the explore model stage, which is a crucial one again, because you just need to make sure that whatever this tool has built out, you are pretty satisfied with that, or like you can just explore different exploration analysis methods over here. So we have like feature visualization, we have the confusion matrix wherein you see the predictions where the against the ground truth, all this values out over here, and the segments, you see they have been rightly classified. If it was incorrectly classified, the color would have been something different, like ranging from light pink to kind of reddish. So it's just to show that it has misclassified that class, and you need to rework on that kind of. So we have all this like results in the form of confusion matrix, feature visualization, wherein you can plot various features across x and y axis to see how well spread they are. You can also see feature embedding, wherein you have three options: the PCA, UMAP, and the TSNE. Just make sure you go through all of this analysis, so that if you're not sure about the linearity of your data, let's say, so just make sure that you go through all this, and they are performing well in all the different analysis. So here you get the information about the features that were used from and which category they were generated from. So they were like from sampling, frequency, and statistical, and the generators were downsample, harmonic, MFE, and zero crossing. So those were the 4 features that were used to create this model, and you again get the summary, model summary of how it performed. You have the pipeline summary, wherein you can just click on each tab out over here, and you get more additional detail about that tab. Lastly, the knowledge pack that would be generated out of it, which would be used for integrating with the actual MCU. Then the last part is testing it out in the real world scenario. So these are the files that we had for like we had for this training, and we had some files left for testing as well. So I'll just test with one file, but it just takes a minute or so. So till that time, let's just go back, and I'll show you really interesting stuff. So at Microchip, we believe in providing customers with the best solutions, right? So we also wanted to do it in the transparent way possible. So what we did was we provided this tool with Python's SDK support, wherein you can actually see what's going behind this UI kind of. So, and also it gives you more flexibility on changing few things if you know of, and or like you just need, you can just get a grasp of what's actually there behind. So you have the option of exporting the whole pipeline into either JSON file, or let's say Python, or the IPYNB, that's the notebook. So what I did was I just exported it to the IPYNB, and I'll show you how it looks like. So over here, this is how the IPYNB notebook would look like. So it's been properly structured just the way it is inside the UI, and you can see like all the steps that went in building those models, or like the other things like the APIs, the functions, or the parameters that come along with it. So you see the when it starts like with the input query, there's the input query's name. You have the windowing, the parameters, the sizes that we set for that. Then you have all the feature generators added to this. So you have like you get visibility of the things going on. So when you are done with it, like you can also add few more to this just by looking at the documentation that we have provided on our website. So it's a exhaustive document. So you'll find a lot of APIs, and you can really play with this a lot, and like change things as you wish. So when that's done, you go to the executing the pipeline that you have built out, and lastly you summarize the results. So we have just mentioned few functions out here, but there are a lot of other functions as well on the documentation page. So just check that out, and you get the flexibility of just playing with this. So there are people who find looking at the code more interesting rather than just looking at the UI part. So we have just added this feature for that.
Hey Kedar, that's excellent input, but I want to add something more here. Like users might have seen this sort of structure in like a data scientist, for example, more familiar with developing in Python, and they have seen more like a software flow rather than a UI flow. So what this gives you is a capability to first understand what's going on behind the scene. Also, you would have seen that every step is well documented. So that's powerful. So anytime you want to change something, you know what's going on. It's easy to debug. And then if you're working in a special use case where you know a certain way of doing things which is better than whatever we are providing here, you can write your own code. And there's nothing stopping you from going as complex as possible here. So that's really powerful, I believe.
Yeah, thanks for that input, Shreyas. So yeah, so that covers the IP/YNB part, like the Python SDK support. But you just try that out and let us know how you feel about that. And so we come back to the testing, what we have left out at. So we see the test file has been tested out with the model, and you see the results down here. So it's 100% accurate. It was like okay, classifying the sensor covered label into that itself. So you get that thing, and you get the heat map and like other classification chart down here, which is like classification versus the time samples that it was processing. So you see the whole green line out here. That's the correctly classified thing. So this being done, we then move to the downloading the knowledge pack. So as I mentioned, this is a 8-bit MCU, so I'll be selecting this one, then putting in the processor name, the compiler. All this have been left out at the default values itself. And also the format would be the library format, because I mean this comes along with the basic license. If you go for the higher end, you'll also have the option to download the source file and then flash it onto the MCU. So, but for simplicity and to show how easy it is to just integrate the library file, I'll just download the library code itself. So once everything's done, and also I forgot to mention, so you have the information about the SRAM and the flash that would be used, the latency, all this on the right hand side. So that also information is really important to correctly make decisions based like if it would go into the MCU or not. So once that's done, so I'll just show you how it's easy to integrate. So I have a downloaded a knowledge pack, wherein you can see, I'll just show you my two screens where it has two, this is on the right hand side, you are seeing the knowledge pack, wherein there will be two folders basically. You'll have an application folder. Inside that you will have the .c and the .h file for the model, and you will have the MPLAB ML folder, where you will have the include folder that would contain all the header files that are required by the library file, and you will have the library file inside the lib folder that would be just a lib MPLAB ML.a, and that needs to be integrated. So how you do that? On the left hand side, I have the base firmware that I used for collecting data. So I'll just go there, inside the header files, I'll click on add files, and then I'll have this application folder swapped into it. Then I also have the other header files that are required for the knowledge pack, like the library file. Those are also included, like the kb.h, kb defines, all these files have been included just into the folder. And also we need to add the .c files in the source files folder. So that also has been added. And lastly, the important part would be adding the library file that has been generated with this knowledge pack. So you just need to click on add files and just swap them in. So it's really easy, no code, nothing. Like you don't need to even touch anything on the firmware side, like the code inside it. So it's just adding those files to the firmware, basic firmware that you had for the data collection, and that's it. That's how easy it is. So I'll just show you how the model works right now. So right now I'm trying to see the output on the terminal. This can be made more interactive, like adding some UI to it, but I've just kept it simple. And This is the terminal that you are seeing right now. So it's showing that the light around it is ambient one. So this is the explained IoT01 board. So that has the light sensor, and this is the AVR 128DA board. That's the 8-bit MCU, and we just have a holder for it, kind of, to integrate. So if I put a light on it, you see the output change to torch full, because it is at full intensity. And if I just cover it again, it will start showing that the sensor has been covered. So like this, you can create more labels and more use cases for this, and like play along with it. Yeah.
Yeah, that's impressive. If someone wants to get started using an ML model, what are some common pitfalls to consider before or during that development process?
Yeah, that's a perfect question. We have been working on this since the launch, and like we have been tracking these things because we saw some friction on that, and like there have been few points wherein we like to guide our customers and like the developers who are using our tool. So the first and foremost thing to remember is you need to establish the hypothesis before even starting developing something or like collecting data. So like they say, problem well stated is half solved, right? Like that kind of mentality even carries on to the AI/ML part. So we need to be very sure about what we want from this project, and like what are we trying to do with it. And so yeah, there needs to be, like, you can't really start off with something thinking that this would help solve this problem, and later on you find that there's no data and the label relationship, and that would create suboptimal performing models. Even though like you put in like exhaustive efforts, it doesn't matter if it's not really connected to each other, and you just like try, but it's not giving you the desired outputs. Remember, Srirag, we had this problem, and like.
Yeah, that's right, Kedar. Yeah, we so what problem we had was the customer was collecting a data that was not reflective of what he wants to deploy it on the field. So the data was working really well in the tool. It was giving 100% result, but once deployed, it was failing miserably. So keeping in mind your ground conditions is extremely important. The model has to see your field conditions as exactly in its training structure as well. So you don't do that mistake. It's a big mistake that some people do it unknowingly. Yeah.
Yeah, that makes sense.
Yeah. So the other point was, okay, so the data pre-processing part. So it's for ML, the underlying statement is that the good data would give you good results. That would yield good results at the end. So you have to make sure that the data you are inputting into the tool is it's really like been processed and like cleaned. The noises have been taken care of, and all these things like that can come along with the data have been filtered out properly. So we do have support for that as well. We really have covered all the use cases that can be added to pre-processing this like the data before inputting. So it's really imperative to make sure that you have the good quality of data to get good results at the end. The third part would be, keep in mind always the target device that you are looking for. Like what are you gonna do with this model that you have created, and which device you would be flashing it onto. So there are many cases where we see that. So for instance, there's this windowing thing that you need to set when you are going for the model building. So you find that there's a good window size that gives you great outputs in the software, but when you flash it onto the device, it doesn't perform well. That happens because the device is not able to support that large size of the window size or the data packages that are coming into it, and the input buffer gets flooded with it, and like it drops off some packets, and the output, that's why it gets hampered, kind of like, and doesn't perform well. So that is one thing that you need to keep in mind.
That's an excellent point, Kedar. So I believe people coming from data science background or software developers are not very familiar with hardware, but they can build really good tools. They would find this point really, hitting home, because you can build a really good model, but you're limited by your processor speed. So your clock speed, the way you take the windows into account has to be paramount. then only you can process it in the field. Otherwise, it's just a good model sitting at home or at a server somewhere.
Yeah, that's another point to remember always while trying out this ML thing. So next thing would be we have provided you with all the evaluation tools that are possible to evaluate this ML models, but make sure you use them, because we see a lot of times that let's say the model is a linear output model, like has data in linear format, so it performs well with the that kind of data and outputs the same thing, but the thing is, like, it may not be performing well with the other analysis, and so you just need to make sure that you use all the evaluation tools that are available. If you're pretty sure about what kind of data and what your application is, then you can just go for that particular one. But like I said, we have in our UI over here that we have the feature embedding, all this analysis out here. So you see how well the data is separated from each other. So it becomes easy for the ML model also to classify them, right? Like if there's some overlapping between them after doing all this feature extraction and everything, there's a possibility that it might fail in that cases. So you need to make sure that it's not underfitting, it's not overfitting. It's just at the optimal level where it performs the best. So make use of this analysis tools out here and just go through all the various exploration options that we have on this UI. The last part would be again. So keep in mind you need to have the performance justified at the right at the starting itself. So what you're targeting to do with this application? Are you looking for something which is really real-time application and you need fast inferences so that you can make decisions based on that, or like or if it's really sensitive things to do, and like if you need more accuracy. So there are different things that you need to set out right before you start building some projects. So those things need to be considered. Yeah, I mean this 5 are the top ones, but we have still few more like that we have identified. But these top 5 would be the ones that you need to look for before starting with any project.
All right. Yeah. So having the right hypothesis, quality data, right parameters, the right hardware, and evaluation process.
Yes.
They're all very important.
Yes.
Perfect.
Now, for those who are still skeptical, don't know if they should use ML, why can't they just write their own program?
Maybe
No, that's an excellent question. So remember the demo we had, Kedar showing ambient light and then a torch that is full and then covered, and probably many more labels can also be included there, like a blinking light or something that's showing a particular pattern. So think about like a developer who's writing a code for all these things. So he or she has to go through so many constraints to just get that one label into code. Like ambient light at this place would be different than sitting outside in the sun or at a certain other fluorescent light. You know, the frequency of light differs. So they have to keep so many constraints into account before writing one label. And here we are talking about n number of labels that can be done just because the data already has those patterns within it, and the model can learn from it. So it just makes the life so much easier for a developer. But yeah, you can always do the hard way, like if you want to, do. But there is always limitation. Human brains think linearly. We cannot do abstract patterns. Not most of the people. So that's why we use tools. So that's why we have this amazing tool we have.
Yeah,
in the name of MPLabML Dev Suite. Yeah.
That's a great point. That sounds great. And then let's see, I have another question. Oh, going back to the tool. Ever since the last live stream, have there been any new updates to the tool?
Oh yes, I forgot to mention that we are constantly beefing up our software suite. We are adding more libraries. We are adding more exploration tools. So it's all keeping in mind that somebody who's coming new to this field, they find it most easy to get through the pipelines, to debug it. So we have you can see in each step how the pattern looks like, or the model looks like, if you're doing it right way, in the building process itself. So that it's keeping in mind to have a good debugging thought process behind it. And then we have added regression analysis into our suite. Earlier it used to be classification. We see a lot of traction regression too. So we are giving the comprehensive solution in the ML field as possible.
All right, thanks so much. And then last of all, most importantly, where can people go to get started?
Everything starts at Microchip webpage. It's microchip.com/ML. From there, you can find, based on use cases, whichever path you want to choose. Either use our tool and build the model right away, or you can use our design partners and get started with them. So all based on your structure, and you can always reach out to us too.
All right, that finishes up all my questions. Clifford, do you have any questions?
I do. So I wrote down some notes while you guys were talking. And for our viewers, you guys should view this as the opportunity to start typing your questions as well, because now is the Q&A section. Up first, you just mentioned regression models, and we talked a little bit about different models earlier. Do we support regression models?
Yes, we do. Right now, it's in Python. It's in the Python SDK. So all you need to do is get into the client. I mean, get the connection and get the, like Kedar was showing earlier. And then from there, start calling the regression model instance, and you're good to go. Like everything that has regression features in the current algorithm, we have it in our tool too.
Yeah,
Okay.
and that's right now. That's currently. I mean, it's currently in the Python SDK, but we'll soon be rolling out the UI extension as well. So it will be available inside the UI itself, where you can just choose that and build out models.
Cool. Sounds very straightforward. Sounds easy. Okay, secondary question. While you were showing off the code, I noticed a line that said TensorFlow Lite. Does that imply that we support TensorFlow Lite models?
Yeah, absolutely. So we do support TensorFlow Lite models, wherein but this support would be always keep in mind that this support is for 32-bit, because the TensorFlow is designed in such a way that it can't be flashed onto the lower one. So right now, what we support is is completely on the 32-bit MCUs and MPUs. So yeah,
Makes sense. What sort of considerations do you guys take into account when choosing models for an application?
So the main consideration would be where, in terms of your hardware preference, right? So are you going to work it in a 8-bit MCU or a 16-bit MCU or a 32-bit MCU? That puts constraint on your resource.
Right.
And once that is, and then the use case is paramount. So what the user wants to do with it, do they want to do it in seconds, or they want to do it in milliseconds, or the speed of inference is also important. Once these two things are figured out, what I want, where I want to deploy the model in, and then what's my resource constraint, then you can look into other optimizing parameters like accuracy, or how to reduce the complexity of the model, how do I deploy it. All those things comes next. So that's the order how we would want to tackle the problem.
Cool. Thank you very much. And I think this may be my second to last question, so anybody in the chat, type away. Okay, so when you were showing off the pipeline, it seemed very straightforward, seemed very easy to interact with. Let's say somebody wanted something slightly different in their pipeline, they wanted to customize it. Can we do that?
Yep, we can do that. So like I mentioned, you already always have the option of doing it in the Python, but
Right.
we have taken care of it inside the tool also. So I'll just show you where it is. So you see these are the sub-blocks inside the pipeline. So there are 3 main sub-blocks that you see, and then there are things that you need to set inside the sub-blocks, like the query and all this. So you see there's a plus symbol in between all these steps. So it's just to help you add new features, or the things that I mentioned. I mentioned for pre-processing, you would be requiring to add, let's say, sensor filter. So you have that option of choosing the sensor filter, and then there's the option of the various sensor filters that are available for this kind of application. So we have mostly covered most of the options that might go in over here. But if you think of something else, you can do it in the Python. But from the UI side, you have these options. Just click on that and set the value that comes along with that function and hit save. So you see it just got added to that. And again, you can just export this to the Python and again play with it over there. That's also possible. Or you just click run pipeline over here itself, and it will be added to the pipeline.
Cool. It's kind of shocking how easy that was for you to do. So that's pretty cool. My last question for you guys is, let's say a customer or anybody wants to use this and they actually create a model. Who owns the model?
It's entirely the customer.
Okay.
Yes, we don't own we only own the tool. It's just like MPLAB X. It supports an ecosystem of different tools and softwares. So it's just like that. It's another plugin within the MPLAB X.
Cool. Thank you very much. Okay, so those were all the questions that I had for you guys. I don't think we have any questions from the audience, but like I mentioned earlier, if you guys are furiously typing away something, just email us at livestream@microchip.com and we will get that information to you. I guess one last note of programming. So the event, Design Week, does not end once this live stream does. Like we were talking about earlier, we have a whole host of, I think, 7 different webinars for you guys today. Our engineers put a lot of work into this, and it's all for you guys on your own time. So check it out, and I think they're pretty good. One last note of programming before I throw it back over to Ulysses is later this month we're having more live streams, another event called Designing for the Edge. I believe it's a series of 6 live streams talking about optimizing your designs. So similar sort of topic. If you guys liked what we talked about today, make sure that you register for that event as well. But I think that's all I have for you. Ulysses?
All right. Thank you, Clifford.
Always.
Thank you, panelists.
Thank you.
Thanks.
It's been a pleasure having you guys on today.
Likewise.
Yeah.
And then as a reminder, if you missed day 1 of Design Week, Managing Security, go check that out. Or if you missed day 2, which was about makers and rapid prototyping, go check that out as well. Thank you guys so much for tuning in, and we'll see you next time.